I want to teach you how to calculate molar mass today. Let's first of all describe what molar mass is, and then I'm going to work a few examples for you. Well, molar mass is the mass of 1 mole of a substance. That seems pretty straightforward. The units of molar mass are the grams per 1 mole. Also pretty straightforward. I don't want you to be tricked though, because molar mass has several names depending on the type of compound you're looking at. If you're finding the mass of an element, it's called gram atomic mass. If you're using a covalent molecule, it might be gram molecular mass. And if it's an ionic compound, it could be called gram formula mass. But all of those names really mean the same thing. It's all molar mass, and the problems are going to be worked the same way. The steps to calculating molar mass depend on you being able to count the atoms of every element in a formula. Once you have them counted, you're going to use the atomic mass on the periodic table for every element, and we're going to add it all together to get that molar mass. Here's an example. Let's look at the compound water. Now with water, when I count, there are 2 hydrogens and 1 oxygen in the formula. Look on the periodic table. The atomic mass of hydrogen is 1 gram. I'm just rounding to the nearest whole number. So 2 hydrogens times 1 gram each is a total of 2 grams of mass. And then oxygen has an atomic mass of 16 grams. There's 1 oxygen, so I do 1 times 16 for that. That gives me a total of 16 grams of mass. So the molar mass for water is the 2 grams from hydrogen added to the 16 grams for oxygen. That gives me a total of 18 grams per mole for water. Now the molar mass is different for every compound, as you might imagine, because the formula for every compound is different. Let's look at this next one. This is calcium hydroxide. In this compound, I have 1 calcium. Remember, the 2 outside the parentheses distributes through the parentheses, so I have 2 oxygens and 2 hydrogens. Go to the periodic table. You'll find the atomic mass of calcium is 40 grams, oxygen is 16 grams, and hydrogen is 1 gram. Those are the same numbers we used in the water example before. Multiply all those together, 1 times 40, 2 times 16, and 2 times 1, and I'm going to add all of that together. So the molar mass for calcium hydroxide, which is an ionic compound, is 74 grams per 1 mole. Now you try. Pause the video now, have your periodic table with you. Remember, for each of these compounds or elements, you want to count the number of each element first, then multiply by the atomic mass for that element from the periodic table, and add them all together. Once you finish, start the video again, and I'll show you the answers. Alright, so here are the answers. For the first compound, you have 2 nitrogens and 8 hydrogens. There's 1 carbon and 3 oxygens. If you've done your atomic mass for each element correctly, you should get a total of 96 grams per mole for this compound. The second one is the element oxygen. Oxygen's diatomic, so I took the mass from the periodic table, which was 16 grams, times the 2, and I get a molar mass of 32 grams for O2. The third one is lead phosphate. Lead, there are 3 of those in this formula, 2 phosphorus atoms, and 8 oxygens, because remember that 2 distributes through the parentheses. Lead's a pretty heavy element, so if you've done your math right, you should get 811 grams in 1 mole of lead phosphate. The fourth example is a sugar molecule. Okay, for glucose, you have 6 carbons, 12 hydrogens, and 6 oxygens. Multiply each element by the molar mass on the periodic table, and you should get 180 grams. And finally, calcium chloride is the last compound. There's 1 calcium and 2 chlorines. Multiply each one of those by the molar mass from the periodic table. Calcium has a mass of 40 grams, and chlorine is 35 grams. When you add all that together, you should get a molar mass of 110 grams for 1 mole of calcium chloride. So I hope those went well. If not, we can certainly talk about them next time we're in class. So I hope that helped. Thanks, and I'll see you next time.